we're going to do problems 6 through 9 on review day 18. Number 24 gives us a differential equation, wants to know which of these would be the solution that goes through the point 0, 3. So initially you should bring the y squared over. It's going to be divided by y squared. We're going to go ahead and change that to y to the negative 2. And then we'll leave the 5 over here with the dx. Now, when we integrate, this goes y negative 1 over negative 1 equals 5x plus c. Doing a little bit of a rewrite here will give us a negative 1 over y equals 5x plus c. That might help us here in a little bit. Let's figure out what that c is. So if I put 0 in for x and 3 in for y, I get a negative 1/3 equal to c. So I'm going to put that in and get negative 1 over y equals 5x minus 1/3. Okay, now if I multiply everything by negative, I get 1 over y equals, I'm just going to flip the order here, 1/3 minus 5x. Okay, you don't have to, but I'm just going to do that. Now we're going to flip things in a second, but when you flip this, you'll notice that that's not necessarily one of your choices. Probably D or E is your choice, right? And if you had to make a guess, because it's minus the x part and it's minus the x part in yours, that's probably your best guess, right? And that is correct. It is D for us here. Okay, now just to kind of tell you why it is, if we were to get a common denominator here, this would turn into 15 over 3, which would be 1 minus 15x over 3. And then when you flip this side, you just flip that over, and that's where that comes from. Okay, so if you're able to do that on your own, great. If you were unsure, hopefully logic kind of took you to that answer. All right. This one says we have y equal to this equation. We want to know which of the following differential equations does this satisfy. So again, this is one of those kind of speed and accuracy kind of problems. We want to go ahead and find the first derivative here, which would be e to the 3x times the derivative of 3x, which is 3, times the derivative of 5x, which is 5, and then 7. So there's our first derivative. And then our second derivative would just be 3 to the 3x times another 3, so 9e to the 3x, and then this goes away. All right, so I'm just going to go ahead and try the first one, and again, you got to be real careful, because if you make a mistake, maybe that one's right, and you go through all this and all of them didn't work, and you get really flustered and whatnot. So second derivative is 9e to the 3x minus 3 times this, 3e to the 3x minus 5 minus 15 equals 0. So I get 9e to the 3x. Negative 3 times this would be negative 9e to the 3x. Negative 3 times negative 5 is a positive 15 minus 15. So what happens is these cancel, I get 0 equals 0. And they were nice to us. They let the first one be true. Okay? If you rush for time, I'd say there's no reason to go through anything else, right? Let's just kind of go off of that. This next one says, what's the limit? And again, the good idea is always to take the limit, or just put the number in, and what we end up with is tangent of 0, which is 0 over 0. So as soon as we see 0 over 0, we know we got a L'Hopital's rule on our hands. So what we need to do is take the derivative of tangent. Hopefully we remember that that's secant squared. And the derivative of the bottom is just going to be 3e to the x minus 3 minus 1. Okay. Now we want to go ahead and try this again. And so if I were to put 3 in here, in 3, we're going to end up with secant squared of 0. Now secant squared is 1 over cosine. We'll put this off to the side here. Secant squared of 0 is 1 over cosine squared 0. And the cosine of 0 is 1. So 1 squared is still 1. So all of that's just going to equal 1 there. So that's not necessarily straightforward, but that's what we're going to get. So not only did you have to know the derivative of tangent, but you had to be able to navigate through what that was when x equaled 3. On this part here, I'm going to get e to the 3 minus 3, so I get e to the 0, which is 1. 3 times 1 is 3. 3 minus 1 is 2. So I end up with C for my answer there. All right, so you got to be real careful as you kind of walk through that. Okay. Then our last one, again, gives us a differential equation and says which of these slope fields would manage it. So One thing you again might want to do is just ask yourself, maybe if I pick a point, what am I expecting? So if I put 2, 2 into this problem, I should get a positive 1, right? So if I'm at 2, 2 roughly, you can see that I'm getting negatives, I'm getting positives. All of these values, all these x, y coordinates are positive. So when you go positive divided by positive, it should be positive all in this quadrant. So this one's not in. These all appear to be positive, so we'll keep that one. These all appear to be positive. These here are negative, so we'll get rid of that. And then this one here appears to have some positives as well. All right, so then if I were to say go to negative 2, so if I go 2 and then down 2, I should get a negative 1 for that. So at 2, negative 2, I've got some so again, in this quadrant, they should all be negative because the x value is positive, the y value is negative. I should be having all negative values in here, so I can get rid of that. This one, all of these are negative, okay? And this one, all of these are negative, all right? And then if I kind of look, now that I've got it narrowed down to 2 of them, I can see that all of these are positive, all these are positive, all of these are negative, all these are negative. All right, so I need something else to help kind of differentiate, right? So I'm kind of trying to look for what's the most obvious thing that, and I think I see it right here at 5, 5. You can see that this slope is really positive. It's a very large number, whereas this one looks kind of like 1, right? It's kind of just a ordinary slope line. And I know from the original, 5 divided by 5 should give me 1. I shouldn't get a very large positive value here. So I'm getting rid of that one and picking E. Now you can go and find some other points that kind of do the same thing for you there, but that's our answer on that one.